record.
Recording in progress.
Okay, we kind of finished up with 13. I think I asked you to, and let's go ahead and just briefly go through these just to make sure you're on the right track for 16 through 29. And then we have a little proof there we're going to do, and then we'll start on the work for today. Now, really, was there any questions for 16 through 23? I thought those were kind of easy, but if you need something, I don't mind. Yes.
On number 18, how would I write the postulate?
3 non-collinear points determine a plane.
Okay, thank you.
You agree with that?
Yes. I didn't think you think at least 3 points.
Well, I'm agreeing with you, but it's telling you that DKH are 3 points, right? And if you observe, the 3 points aren't right on like a traditional plane, right? So you have to kind of look at that and say that they determine a plane, right? I mean, I'm not marking it wrong. I said I'm not asking you to repeat those. I'm just saying you should be able to say they're telling you that those are 3 non-collinear points. So 3 non-collinear points determine a plane. Yes.
Also for 22, I was also just almost right for the postulate.
If the line is in the plane, right? EF, line EF lies in plane Q. So because I'm assuming the points are in the plane, then the line is in the plane. Isn't that what it says? Let's go back and look just to make sure. If 2 points line a plane, then the entire line containing those points lies in the plane. That would be my guess. I mean, isn't that the only one that talks about lines and planes?
So we just write the entire thing.
Well, I mean, I don't know. Just write 2.5 if you want. Postulate 2, just write postulate 2.5.
Oh, okay.
I don't care about that. I mean, I'm not going to ask you to repeat that, right? The stuff that's on the test, I believe, is what I told you yesterday, is the true and false stuff. I think those are good questions,
22.
right? And the sometimes, always, never.
What page is that postulate lesson?
Just going to have to look it up,
It's like a little bit.
right? It's in that section. There's the section's like 3 or 4 pages long,
Okay.
right? Just look it up. Right? I don't have the page number.
Yeah.
Determine whether each statement, does anybody have any questions with 24 through 29? What?
I was confused on like any one of them. You can just pick any one. 26.
If points M, N, and P lie in plane X, then they are collinear. Yeah, you could say sometimes. They don't have to be. They could be. Yes. The intersection of 2 planes can be a point. True or false? Sometimes, always, never. What? The intersection of 2 planes can be a point. Never. It's always a line. All right. 2 planes intersect at a line, not a point. Yes. There is exactly 1 plane that contains non-collinear points A, B, and C. Always, right? 3 non-collinear points determine a plane. They don't determine multiple planes, right? Make sense? Yes.
Was 29 sometimes
Points A, B, and C determine a plane.
or always?
Somebody help her. Tell them.
Sometimes.
Sometimes, of course, it's sometimes. Why?
It doesn't say if they're non-collinear.
That's always on the test. Always. Everybody puts always down. Doesn't say what? Non-collinear, right? a line does not determine a plane. Is everybody good with that? And if all the points are on the line, then it doesn't determine a plane. That's why they say they have to be non-collinear points. All right, non-collinear points form a plane. Non-collinear points form a plane. All right. Anybody else with that? All right, so now let's look at this guy right here. We didn't do this, correct? All right, yeah, we kind of started, right? And then the bell rang and I was shocked, okay? So I was kind of telling you about definition of congruence. If two things are congruent, then their sides or their measures are what? Equal. They are equal. All right, when you talk about congruence, you're talking about shapes. All right, the sides are congruent, the angles are congruent. When you're talking about measures, as soon as you flip over to measures, we're talking about what? Things that are equal. Do I really care? No. All right, I argue with my geometry teacher all the time about that. Something's congruent and equal. Why do we have to change it up? Well, that's just because the way they want you to do it. All right. So right now they are asking you, or they are telling you that JK is congruent to KL. And then they're asking you about equals. So I've got to convert the congruent to what? Equal, right? So now once you establish that for step 2, you're just going to say JK is equal to KL, and that is the definition of congruence. All right, definition of congruence. If you want to go to equal to congruent, it's not the definition of equal, it's always the definition of what? Congruence. All right, why is that? Well, that's because that's what they told me. All right, they're not interchangeable. You don't say definition of equal, you say definition to congruence. When you want to go from congruent to equal, when you want to go from equal to congruence, you use definition of congruence. All right, is everybody good with that? Now, once you say JK is equal to KL, then you can write, somebody tell me what I can write. Thank you. 3y minus 9 equals what? And why is that? Nope. What are we calling that? Tell me. Yay, good job, girl. Substitution. All right, that is a substitution. We're replacing equals with equals. All right. Okay, now here's how I want you to do it. All right, technically we're supposed to put +9 and +9. All right, we don't have to do that. All right, we're just going to write 3y equals what? 24, and we're going to say that's the what? The addition property of equality. And then we're going to write what? Come on. Y equals 8, and that's the what? Right, division property of equality. Division property of equality. Okay, now honestly, I just, now that you know how to do it, hopefully you're saying, well, that's not really that hard. Okay. Everybody good? All right, so now let's look at the next part. All right. Now, we did this, or we're going to do this proof for number 15. All right. So again, you want to write down statement and reason. And honestly, to be successful, a lot of times they're going to tell you something in the proof. Y is the midpoint. Right? So remember what I always told you. Step number 1 is always going to be the what? Yeah, it's going to be the given. All right. And then I have given. And then I'm gonna go ahead and circle this guy again. And that is also part of the given. All right, you don't have to write individual steps for that. Okay. Now, does everybody see XY is congruent to WY, right? So on my picture, you should write one tick mark, one tick mark. Everybody agree with that? Anybody have any issues? Very simple. All right, who wants to tell me why or how do we know that WY is congruent to YZ? How do we know that? I know it's obvious. Tell me.
Because like y is the midpoint.
So yeah, Y is the midpoint. So what does that mean? Say it again.
That means x, y, and y are the same.
Yes. Now, how do we know that?
Because midpoint's in the middle.
Midpoint's in the middle. So here, watch. So again, oh, I hate when that happens. I want you, I just put this up there for you. This is the definition of what? Does everybody agree with me? That's the definition of midpoint. So what does the definition of midpoint say? If M is the midpoint of AB, then AM is equal to what? MB. That's the definition of midpoint. All right. So now I got to fix this real quick. All right. So now under step 2, all right, we're going to write what? Step 2, someone tell me.
X, Y,
Say it again.
X, Y is equal to Y.
Yes, XY is congruent to YZ. Because we're not talking about a measure. Do you agree? All right, XY is congruent to YZ. And of course, step number 2, we would just simply say that's what? That's the definition of midpoint. All right. I always tell kids, if you haven't used the given, right, then you probably haven't done the problem correctly. Now, what are we trying to prove? So why is that? Now, right here, we're going to write, how do I know that XY is congruent to YZ? Or WY, what am I saying? YZ. Sorry, guys, that's a W. How do I know WY is congruent to YZ? Good, man, go.
Because x, y is congruent. to
But what
y,
reason?
because, y, w is the bisect. Wait, no.
Tell her.
Because y is the midpoint.
No. Tell me, Harrison. No, definitely not. Go. What? Tell us.
If X, Y, and Y, Z are both equal, and then X, Y is congruent to W, Y, then it would be the same.
Yeah, but what statement is that?
uh,
I don't want to write all that. Tell him.
Like the definition of congruent or something?
No. Tell him.
Transitive.
Oh. That's pretty good. But transitive has to do with order. Now, what did I tell you was the same as transitive, though, for the most part?
Law of syllogism?
Yes, I did say that. All right, I did say that, but I also said something else. All we're doing. So now look what I'm trying to tell you. In the given statements, right down here, what I want you to notice from step 2, please watch, because I think this is a key. From step 2 to step 3, what is different?
Oh, like 9.
What's different?
The W and the X.
Okay, so I didn't put the line above it. All right, what's different from step 2 to step 3? What changed? The WX, right? So why was I allowed to change that? Not WX, but WY. What was it?
Substitute.
Yeah, it's a substitution. XY, come on, guys. All right, listen to what I'm saying. If you're looking how I got to step 2 to step 3, look what's there and what has changed. XY became what? WY. Because XY is congruent to WY, I can just substitute one for the other. So that's just a substitution. So that's just a basic proof to get you started. All right, is everybody okay with that? All right. And that's why, for some reason, kids have trouble because you're used to just telling me the answer. Now you're not allowed to just tell me the answer. You have to what? You have to do it and you have to explain why that's true. And that's what's annoying. All right. So now let's just jump down to 35 real quick. I didn't ask you to do these, but let's just. No, I don't think it's necessary. I want to get started on today's assignment. This right here is just a review of the postulates. All right. So again, that's not as important. All right. So now what I want to do is go ahead, just put that up. I did it all with you, so I'll give you credit for it. If you want to check, give yourself a check to make yourself feel good, that's good. All right. And now we are going to do 2.5 worksheet. So did I posted the 2.5 worksheet, right? Everybody go in classroom. All right. And today you can put this in your notability if you want. There's a lot going on today. All right. So today for section 2.5. Now, generally, when we get started on proofs, you know, I just pulled a couple examples. And in the past, what I've done is I've kind of whited out the reasons and, you know, I kind of went through, but we're just going to talk it through. All right. And then we're going to go ahead and fill in a couple proofs. That's probably what you're going to be doing on your first test. So you don't have to do an entire proof by yourself starting out, but you'll just have to fill things in. All right. And then eventually I'm just going to give you a statement and reason, and you just have to write the proof, the entire proof by yourself. All right. But right now we're starting out slow. All right. So today we learned something important. All right. Which we already kind of discussed, where this is the most important thing right here. Where it says, if A, B, and C are collinear, then point B is between A and C, then AB plus BC equals AC. We've already discussed that. All right, that's called the segment addition postulate. All right, I'm not exactly sure why they put the ruler postulate in here because I've never used the ruler postulate in one of these proofs. All right, so I don't really think that's necessary, although I think it's important. The points on any line or line segment can be put into a one-to-one correspondence with real numbers. All right. In other words, the number 1 on the number line only occurs what? Once. That's what that means. All right. The number 1 cannot occur twice on a number line. All right. There's a one-to-one correspondence. All right. But again, I don't really use the ruler postulate. The segment addition postulate we use quite a bit. All right, so let's take a look here. And by the way, if you're not sure about something, generally what I do for the test is generally I just go by the proofs that we've done in class. I just grab them and paste them and white things out and say, do it yourself and plug the statements and reasons in. Does everybody understand that? All right, I think that's fair. Okay, so here we go. So up here, notice, and again, the book does things a little bit differently because I like to save myself some time when I'm doing them. I just write all the givens what first, and I just refer back to them. Do you have to write the givens first? No. All right, this is a different perspective. All right, someone else did this proof. All right, so it says Q is the midpoint of PR, R is the midpoint of QS, and I'm trying to prove that PR is equal to QS. Now, I want to look up here and I want you to tell me if that's obvious or not. Is that obvious? Right, can everybody look at that and say if Q is the midpoint of PR and R is the midpoint of QS, then obviously or PR equals QS. That to me is just obvious. Why would I have to prove that? Right, it's obvious. Okay, so now some of you guys who it's not obvious for, let's go ahead and see if it's obvious. So what I mean to do now is Q is the midpoint of PR. So I'm going to mark PR congruent to what? QR. So everybody agree with that? And now R is the midpoint of QS. Well, we already marked QR, right? And we know now that RS is equal to what? QR, right? So that is one tick mark. So what's true about all the segments? They're all equal. Now, again, that's what I'm trying to tell you. That's what I used to argue with my geometry teacher all the time. That's just common sense. Who doesn't know that? That's not what we're interested in. I'm interested in helping you design proofs so you prove things. All right, so you can do that. You can't just say anymore because I said. So now let's see what's involved. Now, again, I understand it's easy because we're just looking at the answers. And it'll work to get it harder, trust me. But right now, as soon as Q is the midpoint of PR, we know that's given, right? Now, everybody should say, because Q is the midpoint of PR, that automatically means what? Yes. PQ is equal to QR. And why is that? Nope. That's the what? That's the definition of midpoint. So anytime you hear the word midpoint, you know you can set two things equal to each other. That's what the midpoint says, definition of midpoint. Then it goes on and says R is the midpoint of PQ, or I'm sorry, QS. Well, you look back at the given, that's what it says. Then the next statement is, why is QR equal to RS then? Tell me. Yeah, that's the definition of midpoint. All right, again, people every year tell me this is so hard. Every year. It's like the hardest thing in the whole world, the proofs. If you don't practice the proofs, it will be hard. If you're following along with me right now, I think you'll be fine. All right, I understand it looks kind of silly because that was common sense, but we're not allowed to write common sense as a reason. All right, you have to list the reasons. So is everybody okay with steps 1 through 4 now, right? Now, Jackson, here's your transitive property, right? It's telling us that PQ is equal to QR. Then notice QR is equal to RS. Therefore what? PQ is equal to RS. Therefore, PQ is equal to RS. That is the what? That's your transitive property. If you write here substitution, do I care? No, I don't care. I don't care. Right? Because you could technically substitute one in for the other. Do you agree with that? All right. Some people like transitive property, some people like substitution. All right. And I used to make kids look things up. What's the difference between transitive property and substitution? And it all is order. Okay. Now the hard part. All right. We are still trying to prove that PR is equal to QS. Do I agree? And I'm still saying, to me, that was common sense, right? But the next statement is PQ plus QR is equal to QR plus RS. Now, to me, that was kind of hard to see that. All right, that's part of the reason why I don't like doing their proofs, because I do it a little bit different. But I wanted to give you someone else's perspective. So why is that? Yeah, well, now, again, I'd like everybody to look up here, and I think this is really helpful if you learn this technique. So we went from step 5 to step 6. What is different? What did they do? The QRs are in there, right? And what's true about QR and QR? They're equal, right? They're the same thing. So all they're doing is adding equals, but we're just used to adding numbers. Are you allowed to add segments? Yeah, you're allowed to add segments. So again, I need everybody to make sure they're hearing me on this. All right. I know it's hard. It's not the most exciting thing in the world. I understand that. All right. But if you want to be successful, you got to focus in and make sure you're hearing me. All right. Because you're going to have to do it yourself soon. Does everybody understand? I'm looking at that saying PQ plus QR. And then I noticed QR is on both sides. So they just added what? They added QR to both sides of the equation. That's why they call it the what? The addition property. I think they should have put addition property of equality. All right, they're adding equals. Now, what does PQ plus QR equal? PR. Do you agree with that? And what does QR plus RS equal? QS. How do we know that? Because it's the what? Segment addition postulate that tells us that's true. Everybody agree?
What does that
What does what
mean?
mean?
The segment addition.
What that means is the parts of the segment added together equal the whole part. Right? That's what that means. Then from there, how do we know that PR is equal to QS? Now, this seems, what do we do? Right, I know it's there, but I'm trying to show you this PQ plus QR is the same as what? I should do different colors. See this right here, guys? That's equal to what? PR. What does this one over here? What's that the same as?
QS.
And I substituted that in right there. Does everybody agree with that? Substitution. All right. Honestly, well, this is just a different perspective. So it can be done differently. And that's what's harder for me to grade your tests, right? You have different ways of thinking about things. And I like what you're thinking. All right. And it's better to write something down. Try. All right. So let's see if we can do something now a little bit different. We have to fill them in. All right. So here we go. Let's try. Number 1. All right. Let's see if we can get this now. Everybody's got to reply. Why is BC equal to DE? Yes. Everybody gets 1 point. All right. Now, given DC is equal to, oh man, I can't say letters today. BC is equal to DE. I marked it. Right? I'm trying to prove that AB plus DE equals AC. Now, I really hope when you're doing a proof, you just say that's common sense. That makes perfectly good sense. Does everybody see that? Can everybody see that's true, right? 100%, that's obviously true. All right, so now we just have to write why it's true. All right, so they're giving you a hint, segment addition postulate. So who wants to tell me what to write? Harrison, good for you. Segment addition postulate. Someone else, help him out. Come on, Jackson. Give me a shot. Good, Will.
AB plus DE.
No, tell me.
AB plus BC equals AC.
Yay, simple. Simple, simple, simple. Very good. AB plus BC equals AC. Brilliant. Right, that's the segment addition postulate. The segment addition postulate can be used when there's 3 points on a line. All right, now remember what I try to teach you is what's different between the second and third line. Michaela,
BCD.
yes, I'm looking here saying what's different. So substitution, yay, we just did our first proof. Substitution. I don't think that's that hard. And like I said, every year I just get whiny. All right. It's different. That's why it's hard. It's different. All right. So here we go. Number 2. Come on, stay with me, Jackson. So it says Q is between P and R is between Q and S, and PR equals QS. Oh, that one's kind of hard. PR, I'm going this way, but 1 tick mark, is equal to QS, and I'm going this way. Is it obvious that PQ is equal to RS? Does everybody agree with me? I think that's obvious, correct? So sometimes if it's not as obvious, right? You can say, for example, I think QR is 5. That means this is 2 and this is 2. So that means QS is 7 and PR is 7. So that's true. Does everybody agree with that? Yes.
How do you know for sure that they're congruent?
What?
Like PR and QS?
PR. Well, we're going to prove that's true, definitely, because that's what they want us. That's what they want us to prove. You're saying you can't see it, right? It's not obvious. So now I'm trying to show you how I know it's obvious. So now the reason what I did up here, and this honestly, I think helped me a lot when I was doing my proofs, was I couldn't sometimes see it. So they told me PQ was equal to RS. Do you agree?
Yeah.
So I just made 2 numbers so my brain could see that they were equal.
Okay.
And then QR can be anything, right? So I just put 5 down.
Okay.
Now I looked at PR, which is how long?
7,
And then QS is what?
7.
So I know it's true.
Okay.
You with me on that?
Yeah.
Now I just have to figure out why it is.
Okay.
All right, that's how I like to do it. All right, because sometimes geometry is not easy for me to see. Definitely not. All right, and I know some of you are having the same thing. It's obvious, but not to everybody. All right, so now let's look. So come on, guys. Come on, participate. All right. Let's get it done. That's the only way you're going to get better. You got to try. I don't care if it's wrong. All right. I know it's not the most exciting thing. All right, but you got to try. Q is between P and R. Why does PQ plus QR equal PR? Tell me. Segment addition postulate, and we can abbreviate that SAP. Segment addition postulate. We use that a lot. All right. Come on, guys. You're supposed to be telling me how much you can do right now. All right. If you can't do any of it, you got a lot of studying over the weekend. If you're pretty good at it right now, then you don't have much studying over the weekend. So why is R between Q and S? That's the given. Segment addition postulate is their next reason. So some brave soul. Harrison, try it again.
RS plus RQ equals SQ.
Yeah, but I want you to say it in an orderly fashion, right? So we're talking about this segment right here. So now read that the two segments.
QR plus RS equals QS.
That's very good. Even though what you said before wasn't bad. QR plus RS equals QS. What?
How did you know 3 was a given?
I read the given. Didn't I? Did you read it? Do you see it? Now, again, normally I put the given in order, right? I mean, I put it right next to each other. They don't like to for whatever reason. All right. Now, why is PR equal to QS? Tell me. Substitution. Now, why is PR? Oh, yeah. I'm sorry. So look up here. I forgot. But look right here, though. That's why I just don't like to list the given. You see what I mean? I just don't. I was overlooking that myself. I was trying to figure it out. All right. That's why I like to just list the given all in order. You agree with me? And I even marked it up here. Right. So we know that PR, I'm going to erase this now because this confused me. We know that PR is congruent to QS. That was given, right? All right, so that was my fault. That was given. And like I said, I like to put all the givens at once because I just like to organize my thoughts right up front. That's what I would do. All right. Now, tell me, Nate.
Addition property.
PQ plus QR. PQ plus QR. Sometimes it's right above, sometimes it's not. Right, so let's figure out why you weren't correct. You're looking here to here, right? So you see QR is being added, right? But you see it's not the same from up here. Am I making sense to you? Like I'm agreeing with you, they added QR. This is where you have to do a thinking, right? They added QR, do you agree?
Yeah.
But this right here isn't PQ and this right here isn't RS. Do you agree with that?
Yeah.
So now we're going to do again. So that's good though. So I'm looking at 5 to 6. How did I get from 5 to 6? It looks to me like PR became what?
Substitution.
Right. I think so. Right. So I'm trying to show you guys, and honestly, I know it's hard. All right. I know it's hard until you practice. So PR became PQ plus QR. Is that acceptable? Because they are what? They're equal, right? So this was a substitution. It's kind of a substitution twice. Do you agree? Because what did QS become? Yes, QS became QR plus RS. Does everybody agree with that? Now, again, I'm trying to tell you, it's no good to just write things down, right? I'm trying to get you to ask me a question if you're not seeing something, honestly. All right, everybody okay with that? What? Where does it, QS, what does QS equal?
Yeah. Oh, wait.
Look at line 4. What does QS equal? Right? So I replaced QS. I replaced QS with QR plus RS. You see that now? Then, if you want, I'm going to use a different color because I think it's important. right? I'm gonna say PQ, QR, PR, and PR, they're equal. You with me now, right? Makes sense. And again, like I say, usually it comes right from the step below it. Sometimes you got to creep back up a little bit and see. All right. Now, somebody help me out with step 7. What?
Subtraction.
I like that, girl. Good job. Subtraction property of equality. Because all we're doing is we're eliminating the QRs, right? And now what? PQ must equal what? RS. All right, and that's a substitution. All right, because QR minus QR is 0, so we're substituting zeros in. All right. Okay. That was fun, for me anyway. All right. All right, here we go. All right, let's just come up here for a second. Let's do skill practice. Just skip down one. All right, because the bell rings in 10 minutes. All right. Just for practice, why does QA equal QA?
The property of equality.
Something is equal to itself. What property is that?
Oh, the A.
Yeah, it's called the reflexive. Reflexive property. All right. So in the past, we said X equals X, right? Sides equal sides. All right, now let's look at this. If AB is congruent to BC and BC is congruent to CE, then AB is congruent to CE. Why is that? Nope. Come on. AB is congruent to BC. BC is congruent to CE. Therefore, AB has to be congruent to CE. What, Maren? Yeah, you could call it substitution, but they prefer what? They prefer transitive. If you put substitution, do I care? No. How do I know it's a substitution? Because the order, right? The order is important. AB, BC, BC, CE, therefore AB, CE. All right. And like I said, if you never use transitive property and always use substitution, I don't care. All right, number 3, if Q is between P and R, then PR equals PQ plus QR. SAP, very good. Segment addition postulate. Okay. All right, let's look at this one carefully. AB plus BC equals EF plus FG.
So,
And AB plus BC equals AC. Then EF plus FG equals AC. Now, is this a correct order? Could this be the transitive property? No. It would have to be a what? It would have to be a substitution. But now look, does everybody agree? Watch what I could do here, guys. And please listen to this. All right, if I did this right here, put that right there, and then I put this right here, and then put that right there. Now could it be a transitive property? EF plus FG equals AB plus BC. AB plus BC equals AC. then what? EF plus FG equals AC. Now it's a what? Transitive property. Does everybody understand what I'm saying? Right, go, tell me.
How do you know it's supposed to be that order? So,
Because that's what the transitive property says. Right, the transitive property says if X equals Y and Y equals Z, then X equals Z. I keep trying to tell you, it has to be in that order. It has to be X, Y, and then Y is to Z. That means X equals Z. Do you agree with that? That's the transitive property. Do I care?
no.
No, I don't care. That's why it's annoying to me. Because I could have just used the symmetric property and switched this around and then said it's a transitive property. Right? It doesn't matter to me. That's what I'm trying to tell you. If you write transitive property, that means you understand it's got to be in the right order. Substitution, if it's out of order, it's the substitution. That's all I'm trying to tell you. All right. And I'm not a pain about grading your proofs. I think it's more important to try to figure out, hey, how did I get from here to here? All right. The details, not as important in my opinion. All right. So I'm not a pain about it, right? I'm just saying those are what the book wants. That's like the formal stuff. People ask mathematicians, you tell them what's the difference between substitution and transitive property, they'll go crazy if you don't know, right? To me, it's the same. All right. Okay, so let me see here. Oh, there's a lot. All right, so I don't know. We get out at 9:05, right? Okay, so I don't really have time to do. All right, so what we're gonna try to do on Monday is I'm gonna try to continue on practicing a couple of these proofs. All right, and then we'll start 2-6. All right, but you guys, listen, if you're going, oh my gosh, this is so hard. To Monday, I'm gonna go through these proofs. All right, if you want to give it a shot over the weekend because you're nervous about it, give it a shot. If you're like, oh, that wasn't so bad, then it's not. All right, it doesn't matter to me. All right, you guys rest a little if you want. Some of you guys, if you want to try a proof and then, when you come back on Monday and I'll have it done for you, you can see how good you are. All right, Lucas. Can you hear me?
Yeah. Yeah.
All right, buddy. Sorry, man. Yeah. Have a good weekend. When are you coming back?
Probably Monday.
All right. Great news, buddy. Have a good weekend. Hopefully you got everything. Take care, buddy.